All right, today in Algebra 2, we are going to finish up section 7.5. We are going to look at graphing secant and cosecant. So it says, what are the key features of the graph of y equals the secant of x? Okay, so let's remember that the secant of x is equal to 1 over the cosine of x. Remember that cosine is max O min O max. We know that the cosine is undefined, or sorry, is 0. Back to that. We know that the cosine is 0 at pi over 2, 3 pi over 2, odd multiples of pi over 2. Therefore, the secant, if I flip that 1 over 0, I'm going to get undefined. So I know I'm going to have vertical asymptotes at all our odd multiples of pi over 2. So we'll go ahead and put asymptotes in at odd multiples of pi over 2. So then let's start testing these points. So halfway between negative pi over 2 and pi over 2 is 0. So let's see, what is the secant at 0? So at 0, my cosine is 1. So 1 over 1 is equal to 1. So I know at 0, I'm up here at 1. If I wanted to see what is the secant, okay, at pi over 4, halfway between, this would be pi over 4. So the secant at pi over 4, I know at pi over 4, my cosine is the square root of 2 over 2. So if I flip that, 2 over the square root of 2, I have to rationalize. So I get 2 square roots of 2 over 2, which is going to be the square root of 2. So that's a little bit more than 1. Okay, so I know I'm a little bit more than 1. So then at negative pi over 4, I know I'm going to be the same thing up here. If I look at the secant of pi, I know at pi, my cosine is negative 1, so I'm looking at negative 1 over 1, negative 1. This would be 3 pi over 4. So if I want to see what is the secant at 3 pi over 4, so at 3 pi over 4, my cosine is negative square root of 2 of 2. So if I flip that, I'm just going to end up with the negative square root of 2. So I know I'm a little bit past 1. Same thing for 5 pi over 4. I know that my graph has to get close to my asymptotes but not touch it or cross it. So we actually see here, we're going to get parabolas in here. And they're going to alternate, one up, one down. So then I know here I would have one coming up the other side again. So then here I know I would have one opening down. Here I would have one opening up. And if you want to see something that's really neat about this, okay, so I know that the cosine starts at 0. It's max O min O max. Go this way, okay, max O min O. Okay, drew this one wrong. Sorry, this one would have started up here at 1. And there's my max. So remember, this is what my cosine would look like in green. Where my cosine is 0, my secant has vertical asymptotes. Where my cosine has a maximum, I have a parabola opening up. Where my cosine has a minimum, I have a parabola opening down. So you can always graph the cosine and then you find your vertical asymptotes, and you know which way your parabolas are opening that way. So then let's identify all of these key features. So the domain, okay, of my secant, again, I notice that I have vertical asymptotes of all the odd multiples of pi over 2. So my domain is going to be all real numbers except odd multiples of pi over 2. My range, my parabolas, I see start at negative infinity and come up to -1. So I have negative infinity to -1 union, then they jump up +1 and go all the way up to positive infinity. As a period, okay, so the entire graph consists of this parabola and this parabola. So from -pi/2 to 3pi/2. So that is a period of 2 pi. So one period of the secant consists of the two parabolas, one opening up, one opening down. This will have no zeros, so the secant function will never be on the x-axis. Its parent function is not on the x-axis, doesn't have any zeros. Vertical asymptotes, odd multiples of pi over 2. It is increasing, okay? The parts of the parabolas, so my parts of the parabolas that are increasing, is where my graph is increasing. It's decreasing where the parts of the parabolas are decreasing. Positive above the x-axis, negative below the x-axis. So now let's look at the cosecant. We know that the cosecant is equal to 1 over the sine. Remember that sine is O min O max O. So if I look at the cosecant at 0, so at 0, my sine is 0. So 1 over that is going to be undefined. I look at my cosecant at pi over 2. Pi over 2, the sine is 1, so 1 over 1 is 1. I look at the cosecant halfway between there, let's say at pi over 4. The sine at pi over 4 is square root of 2 over 2, so I know when I flip that, I'm going to get the square root of 2. The cosecant, we'll look at pi. Again, at pi, the sine is 0, so when I 1 over that, I'm going to get undefined. So I see that at 0, I have an asymptote, so we'll go ahead and draw that in. At pi, I have an asymptote. So I'm going to have another asymptote at negative pi, 2 pi, negative 2 pi. So we said at 0 we're undefined, asymptote. Cosecant at pi over 2, we're up at 1. Pi over 4, square root of 2, so that's a little bit open. If we look at the cosecant at 3 pi over 4, 3 pi over 4 would be this spot right here. It's going to be, again, the square root of 2. So again, I'm going to have a parabola. So then this one is also going to give me parabola opening down. So the secant and the cosecant look very similar to one another. It's just where their asymptotes are that are different. And again, if I wanted to see what is the sine function, so I know the sine starts out O max O min O. So this is our sine function. And again, we see where the sine function is 0, the cosecant has vertical asymptotes. Where the sine had a maximum, I have a parabola opening up. Where the sine has a minimum, I have a parabola opening down. So my domain of the cosecant will be all real numbers. except our integral multiples of pi. Period again is 2 pi. The range is just like the secant, negative infinity to negative 1, union 1 to infinity. We will never have any zeros with the parent function of the cosecant. Vertical asymptotes are our integral multiples of pi. Increasing, again, the parts of the parabola that are increasing. Decreasing on the parts of the parabola that are decreasing. Positive above the x-axis. And negative below the x-axis. So now let's look at graphing some of these when the period changes. So the first one we're going to look at is y equals 2 times the secant of 2x. So the very first thing we want to do is find what is the new period. We still use the 2 pi over b for the period, just like the sine and the cosine. So 2 pi over 2 is going to equal pi. So now I have a period of pi. I need to find out my new asymptotes. We're going to find these the exact same way that we found them with the tangent and the cotangent. So the secant original asymptote is at pi over 2, negative pi over 2, right? So negative pi over 2 equal to my b, 2x. When I cross multiply, I get 4x equals negative pi. So x equals negative pi over 4. If I did pi over 2 equals 2x, again, I would get 4x equals pi, so x would be pi over 4. I know at negative pi over 4 and pi over 4, I have asymptotes. Let's see, pi over 4, negative pi over 4. So then I know I would also add at 3 pi over 4, my next, all of my pi over 4s. So I'm going to go ahead and put asymptotes in here. Right, so now, let's see, halfway between 0 and pi over 4 is going to give me a pi over 8. This would be negative pi over 8 if I wanted to keep going, okay? So this would give us 3 pi, halfway between pi over 4 and 3 pi over 4 is going to get us pi over 2. So then this is going to give us 3 pi over 8 right here. This would be 5 pi over 8. I want to go the negative direction. Negative pi over 2 is going to be a negative 3 pi over 8. Negative 5 pi over 8. So now I could just start plugging these in. Okay? So 2 times the secant of 2, let's say I'm at 0. So looking at 2 times the secant at 0. So at 0, I know that my cosine is 1. So if I flip that, I still get 1, so I'm at 2. So at 0, I'm up here at 2. So then I'll go pi over 8. So 2 times the secant, 2 pi over 8 will equal 2 times the secant. This turns to pi over 4. I know that pi over 4, my cosine is the square root of 2 over 2. So my secant is going to be 2 over the square root of 2. So when I flip that, I get the square root of 2. Then I have to multiply it by this 2 out here, so 2 square roots of 2. So over here, up a little bit. So it's the same thing on this side. So there's my parabola. But then I know negative 2. So at pi over 2, I'm going to be down here at negative 2. Parabola opening this way. So I would know my next one over here, negative pi over 2. Again, parabola opening down. If I wanted to keep going out this way, again, if I wanted to look at that cosine function, I know that it's 0. Cosine starts here, so max, and then O min O max. So there's my parabola opening up. There's my vertical asymptote. There is my minimum, so my parabola opening down, 0. So parabola opening, or sorry, vertical asymptote, back to a max, parabola opening up. So now let's look at y equals 3 times the cosecant of 2x. Again, we need to find the new period. So the period is 2 pi over b2, so we have a period of pi. We want to find our new asymptotes. The cosecant had original asymptotes at integral multiples of pi. So I know at 0, right? So 0 equals 2x. I know I'm still going to have an asymptote at 0. So integral multiples of pi. So then at pi equals 2x. So now I'm going to be x equals pi over 2. Negative pi equals 2x. I'm going to have a vertical asymptote at negative pi over 2. So if I wanted to go ahead and draw this in, so I know at pi over 2, negative pi over 2, have vertical asymptotes. And it's 0, so let me switch colors here. So I know 0, pi over 2, negative pi over 2. So between 0 and pi over 2, right, I have a period, or sorry, a space of pi over 2 units. So if I wanted to continue out to my next asymptote, it would also have to be a space of pi over 2 units. So then pi over 2 plus pi over 2, this would be at pi, and this would be at negative pi. I can see that I'm multiplying everything by 3. So I know I'm going to go up to positive 3, down to negative 3. Halfway between 0 and pi over 2, or at pi over 4. So then this would be a 3 pi over 4. And this would be negative pi over 4. Negative 3 pi over 4. Or at halfway between 0 and pi over 4, we're at pi over 8. So this would be 3 pi over 8. 5 pi over 8, 7 pi over 8, same going the negative direction. So now if I wanted to graph this, again, without having to really plug anything in, so I know that the sine started at O, so I know that this is a vertical asymptote. Then we went maximum, so I know that at pi over 4, I'm going to have my parabola opening up. It's since I'm multiplying by 3, I started at positive 3, parabola going up. So then O puts me back at a vertical asymptote, minimum at the 3 pi over 4, so I'm going to be down here at negative 3, my parabola opening down. Same going this direction, so negative pi over 4, I know parabola opening down. Negative 3 pi over 4, up here, parabola opening up. All right, so that gets us the 3 cosecant of 2x. We did actually have 2 cycles graphed here because remember that a period was pi, so from 0 to pi, that's my first period, right? And then 0 to negative pi is another period. So we have 2 cycles that we've actually graphed there. So let's do one more of each of these. So now we're going to look at negative 4 times the secant of 1/2 x. So again, I need to find my new period. So 2 pi equals 1/2, sorry, 2 pi over 1/2. I was working on the asymptote there. So 2 pi over 1/2. When I flip and multiply by 2, I'm going to get 4 pi. So I have a new period of 4 pi. So now I'm looking at for the new asymptotes. Remember that the secant function originally has asymptotes at odd multiples of pi over 2. So if I do negative pi over 2, set that equal to 1/2 x. So I have negative 2 pi equals 2x. So x is at negative pi. If I did pi over 2 equal 1/2 x, again, I'm going to get x equals positive pi. So let's see, I know at pi and, oh, I don't know where that color came from. I guess I hit that with my thumb. Sorry about that, guys. So then pi, negative pi. So I know I've got asymptotes here. And I know at 0, oh, sorry, not at 0, not at 0. So I know that between negative pi and pi, asymptotes, I have a, so that's going to give me one of my parabolas in between there. So my next parabola, okay, again, I need a, between negative pi and pi, that's a unit of 2 pi. So my next asymptote is going to be 2 pi out more. So this is pi, here's 2 pi, here's 3 pi. And if I wanted to go the negative direction, go out to negative 3 pi. So that's what my next asymptotes are going to be. At negative 3 pi to get me the same spacing. So halfway between negative pi and pi is 0. Okay. We have 4 and negative 4. The only thing on this one, we see that it's a negative out here, so I know that instead of my very first parabola opening up, it's going to open down. So at 0, I would be at negative 4. This way. Between 0 and pi, we're at pi over 2. This would be negative pi over 2. So then that means that this is going to be 3 pi over 2 and 5 pi over 2. Our parabola opening up. We would also have the parabola opening up on this side if we wanted to keep going. So if we wanted to go ahead and plug these numbers in here, so let's say I plugged in pi over 2, so negative 4 times the secant 1/2 pi over 2. So then I have negative 4 times the secant, so 1/2 pi over 2 is really the secant at pi over 4 that I'm looking at. I know at pi over 4, my cosine is square root of 2 over 2, so when I flip that, I'm going to end up with just the square root of 2, but I am multiplying that by negative 4, so negative 4 square roots of 2, and that's what's going to put us a little bit past that 4. Again, if I wanted to see that I had just wanted to graph the cosine function, I would just have to notice this negative out here. Right? So this negative out here tells me that instead of starting at a max, my cosine would have started at a min. So min, O, max, O, and then again min. So I'd have another parabola opening down this way. I wanted to see that cosine function or not graphed. We do not have to draw the sine and the cosine graphs on here. All right, so the last one we're going to look at, y equals negative cosecant 1/2 x. So again, we're going to find the new period. So 2 pi over 1/2 is going to give me 4 pi. We're going to find the new asymptotes. Remember that the cosecant originally had asymptotes at the integral multiples of pi, so 0, pi, 2 pi, etc. So if I do 0 equals 1/2 x, I'm still going to have an asymptote at 0. If I do pi equals 1/2 x, then I'm going to get x equals 2 pi. negative pi equals 1/2 x. X is going to equal negative 2 pi. So we'll draw these out. So pi, oh, sorry. Negative pi. So I know asymptote, I'm at 0, I'm at pi, I'm at negative pi. So I know that my first parabola is going to be between hold on. Sorry, I had labeled that wrong. I wrote over here correctly that this is 2 pi and negative 2 pi are asymptotes. Okay, so I know that between 0 and 2 pi is my first parabola. Okay. So, and I know that I have a period of 4 pi. So then I know that this is going to end out here at 4 pi. It's going to be my next asymptote because it has to be the same distance. So between 0 and 2 pi is 2 pi units. So between 2 pi and what gets me another 2 pi? So 2 pi plus 2 pi, 4 pi. So then if I wanted to go out this direction, again, I would be at negative 4 pi. Again, I'm just going to be 1 and negative 1. Again, I notice this negative, so I'm just doing the opposite. So instead of my first parabola opening up, it's going to open down. Okay, so halfway between 0 and 2 pi is going to give me pi. So that's going to be at 1. And so then this would be pi over 2. This would be 3 pi over 2. So my parabola. So then halfway between 2 pi and 4 pi gets me 3 pi. This would be, let's see, 5 pi over 2, 7 pi over 2. So this is my parabola opening up. If I wanted to continue, I know this one would be going down. So this would be at negative pi, opening up. This is negative pi over 2, negative 3 pi over 2, negative 3 pi, parabola opening down. So that's how we graph the secant and the cosecant. Again, you don't have to just like this. So if you go to Desmos and you were to type in, negative cosecant 1/2 x, it's not going to graph the sine function and then the parabolas. It's just going to give you the parabolas and the asymptotes. Graphing the sine and the cosine and then just using that as your guide to draw your parabolas is just kind of a little guide to help you. But definitely the sine and the cosine are not part of the graph of your secant and your cosecant. Right, so that wraps up day 2 of 7.5. Tomorrow we will look at the graphing transformations of sine, cosine, tangent, cotangent, secant, and cosecant, where we actually have vertical and horizontal shifting of those.